Hello, in this video we will focus on time-based representation in Grasshopper, and we could summarize that as doing animation in Grasshopper. So I want to give you a preview of what we'll be looking at. In this case, I am moving a slider, which allows us to look at plotting of a time-based variable, in this case sound, in an urban space. So I'm able to create a camera, follow the camera, have a target set up on the variables that I'm plotting, but also there's some environmental elements that I'm representing. In this case, the volume of each buildings for sake of showing a variable. So I can go back and forward, and as you could see, slider in this case is acting as a timeline of an animation. So we will begin the tutorial by just looking at the concept of creating animation in Grasshopper first. Then we will move on to this specific example, which I've provided the base file for you. So I'll be opening a generic file, and I'll be working in small object meters, and I am in perspective view. I'm going to open a new definition. And the idea is to look at the concept of changing variables, but look at that through a time-based factor, through animation. So in this case, I would be constructing a series of random points. These random points will be three-dimensional. We will construct a mesh surface through them. And then by changing number of these points, we look at how our mesh surface is behaving. Let's go to our vector tab, to our grid. So inside here, we have a series of different ways of not only creating grids, but creating a random population to begin with. So I'm starting with, in this case, a component called population 3D. So you can see that it is starting with a three-dimensional bounding box, which is preset here. So this is the region. If I right click on it and tell it to set one box, I could just randomly click on a base, click on height, and it takes that volume and it's populating it randomly, random positions with however many counts or number of seeds that we want to incorporate in this component. In this case, this is set up to 100. I'm going to change that number, one less than, let's say, 200. And we can see that how the population is changing. Now we are working with the concept of randomness here, but in computation, randomness doesn't really exist. Randomness is always a domain that you've set up, and you are picking a series of numbers, but only within that domain. So one of the variables that allows you to work with randomness is this thing called random seed, or seed in this case. So a random seed is a value that would guarantee that our results would always be the same given the same setup. So this random seed will guarantee me that, let's say, when I have 200 points or 100 points, this is what it's going to look like. So imagine it's a way for you to be able to predict randomness, which sounds counterintuitive, but sometimes, let's say, a specific type of randomness you prefer. But this is something that we can change. So if I set up another variable, and again, this slider would be, imagine, number of possibilities that you can create within this design space. So let's say one less than 100. Every time that I change this value, it would be similar to, imagine, tossing your ball and changing the possibility, the size that it would stick on, right? So number of elements within this boundary is the same, but their configurations are changing. So this number would guarantee that anyone with this Grasshopper installation, if they have this same number of counts and same value of random seed, they would get the same result. So it's not really that random. Here we can start to add external points, but I want to just work with what I have. So the population is a series of points that are three-dimensionally distributed. And I'm going to go to my mesh tab. under triangulation, I want to work with a component called Delaney mesh. So by default, we'll see that there's an XY plane preset here. I'm going to turn off my grid here and just feed the population of the points to the Delaney mesh. So I'm going to turn off my population component, and you'll see that actually it is creating a surface throughout these points. And what's interesting about this, even though my population elements are kind of, it seems like they're all over the place, but if I were to look at their point list, their index, and so under display vector point list, I'm going to use a value here, 0.1 less than 10. So if we start to look at their values, you'll see that not all the numbers are distributed next to one another, right? So how does the Delaney mesh know that when it's creating the surface? In this case, the vertices are not distributed all over. So the way that the Delaney mesh works, it looks at a population of points, and it is resorting them based on their x and y coordinates. So you could start with a random population, but it gives you a really nice distribution. Similar to this component, which returns a mesh, under triangulation, we can use the Delaney edge. So it's the same setup, but instead of returning the mesh faces, it returns the mesh vertices. Right? So same thing. And I could, in this case, I want to go with the mesh surface. So we're going to keep the XY plane. We're not going to worry about that. But because I want to animate this, I do not want to see the plane. So by default, the plane is an 8x8 grid. We can go to our we can go to our display menu. Down here where it says preview plane size, we can change the scale of this. I can do something really small, 0.1, enter. So it becomes really, really small. But if I absolutely do not want to see this, I would just grab a mesh container and I would just completely turn this off, right? So we're only looking at that. Right, so what I want to animate here is how by changing the count, my mesh is starting to change. But you're starting to see that when I have one value, it's giving me an error. Well, I'm telling it to create a mesh triangulated Delaney surface, but it's not able to do that with 1 point. How about with 2 points? No, we at least need 3. Right, so I'm going to just click on 3 for us to have a polygon mesh. So this is a triangulated mesh. So what this tells me is that I might as well just change my minimum to 3. So this is number of points, which then would result in number of meshes. So this is a quite interesting setup. Now the size of these meshes are just based on the regions. Larger this box, larger the boundary that we would distribute. So somehow through animation, I want to animate this process. So anything we see on our screen, whether there's a combination of Rhino and Grasshopper, we're able to screenshot. So the screen is able to capture the overlay of these two, Grasshopper and Rhino, or just Grasshopper or just Rhino. And if we think about the concept of animation as, if we were to simplify it, for you to have an animation, you need at least 2 frames. So if you have 2 frames, there's a beginning and end frame. You're able to tell a story. And what is important here is the fact that these 2 frames need to be different from one another. So there has to be a variable that's changing. And perhaps there's a time-based factor associated with that. So if we think about an animation, then we can think of a slider as an animation timeline. If you grab any default slider, and this might be a feature that you've never paid attention to, but if you right-click on the slider, I'm going to move this up so we can see this better. Right-click on the slider, you're going to see an option to animate. So as soon as you open that, we are able to see an animation window here. So the very first thing is, where do you want to save that to? I'm going to browse, and I do have a folder created on my desktop called GH animation, and I'm going to reference that. So it's an empty folder. The next thing we can set up is the time of a file that we are creating. So as you're going to see, if this is your first time doing this, your file type is going to be a bitmap file type. But I don't recommend using bitmap file types, as if you were to plug this into an animation compilation a software, a lot of these, such as After Effects, they do not like working with bitmaps. So all you have to do is to change the extension to, let's say, JPEG or PNG or TIFF. So whichever one you prefer. For this, let's just go with JPEGs. The next thing we could see is the viewport that we're on. Whatever you have set up, the first thing when you launch your animation, you're going to see that. So I'm in perspective, but if I drop that in the menu, I'll see the top view. Now, if I had my grid turned off here, I would also not see that, but I don't. And whichever one you want to set up. I'm going to go back to my animation. The next thing we can set up is the resolution of our screen. So by default, we're starting with one of the lowest ratios, 640 by 480. We can manually overwrite this, or if you click on the icon of your viewport here, it's gonna adapt to whatever your viewport size is. So in my case, it's more landscape, so it adapts those values. Again, you can override that. Next thing we can look at is a number of frames that we can extract from a slider. So this number is directly related to the type of sliders we have. So for instance, if I'm using a default slider between 0 to 1, and if this slider has 3-point decimals, I could potentially get 1000 frames out of this, right? So every frame would be 0.001 interval different from the other. But just because my slider allows me to have this many frames, it doesn't mean that I should. So for instance, I could, in this case, go with 10 frames. So in this case, I would skip. I'm going to go from 0, 1, 2, 3, right? So I would pretty much be using integer numbers. The next thing I want to be using here is an option, whether we want to include a tag on our image or not. This will help you to later on, if there's a frame missing, or if you want to evaluate your geometry within this animation, you can take a look at that. So let's check this, and we would see if you want to keep that or not. And then all we have to do is to tell our, just press OK. And you saw that immediately my slider went to the beginning, 0, and it started to move. And here, it should also tell me when it's generating this animation. So it tells me that it created 10 frames. So at this point, let's go to the default animation folder I've set up. And here you should see series of images. So this is screenshot quality. It absolutely adapts the background, also my orientation icon, so we can turn all of this off, and you see the tagging. And as I go forward, we're starting to see that in this case we were animating a slider that was not really related to anything, but we do see the values changing here. So let's go back and replace this with a proper animation that would show us how our geometry would be responding to the change. So I'm going to delete this default slider that I have, and let's go to our count slider. Right click on the count slider, animate, and we already see that it has our presets stored here. So I would browse and select my GH animation folder. Okay, and I could keep this in the same setup, or instead of frame, I could call that animation test, so whatever we want. So this number of digits here would allow us to have that many versions, right? So if your slider has 3-point decimals, or it's a large number, you want to be able to have as many zeros as possible. So then otherwise you're going to start to rewrite your images. I'm going to keep the same ratio, and instead of, in this case, 10 frames, I would be doing 50 frames. So it's going to take whatever your slider is, in this case 200, and it's going to extract 50 instances from that. And this time I'm not going to include the tags. So go ahead and press OK. So you'll see that as the slider is going forward, my geometry is starting to change. And go back to your folder. And again, we do see an interesting representation here. Right. So this works for you to quickly just document possibilities of your geometry. But one of the important additions to this type of animation would be working with your camera properties. So this camera property could be setting up the position of the camera, position of your target for your object, as well as the lens type that you're applying to for your camera. So I'm going to delete these. I'm just going to be using the default folder for that. So for that, I'm going to be working with a plugin called Horster. I'm going to go to my browser and look for Horster on Food for Rhino website. When you search for this, you're going to have two options here. One is Horster reference for Grasshopper, and the second one, Horster camera control for Grasshopper, which is the one we want. So go to this page and make sure you download the latest version, which is actually the only version available. For this download, make sure that you unblock the zip file, and after that, going to go through that process. Right click, go to properties, unblock, extract your file. And you have the example files as well as a GHA file. And what you want to be doing is to install the GHA file to your file menu under special folders, components folder, and Horster. You would just drag and drop that here. I already have that here, so I don't need to do that. If you install your plugin this way, you just have to make sure that you close Grasshopper and Rhino and restart. When you restart, you're going to see a tab appearing for Horster. And this tab only has 3 components. One is Animate Camera, Get Camera, and Set Camera. We will be using our Set Camera component, which looks like most preview components, that it doesn't really produce data, but it just creates previews. And this component allows us to work with important attributes such as camera location, target location, and lenslet. For the camera location and target location, it is ultimately asking for a point. So let's create a point. In Rhino, I'm going to create 1 point, which is going to be my location of the camera. I'm going to select this point and with my gumball move it up. And I'm going to create another point right in the middle of my geometry, maybe a little bit higher, and that's going to be my camera target point. So we just have to see whether we like this angle. We would adjust that. I'm going to reference them with a point container. I'm going to use one for my target. I'm going to place that where it says camera target, and I'm going to group it to itself and say camera target point. I'm going to make another copy of this container, move it down. First, I'll change the name. This is my target point. And I would right click and do clear values. I'm going to right click on it again and tell it to set 1 point, and I will select my target point. I'm actually going to right click and change the name to just target point. be more simplified. And I'm going to place that to where it says target location. So the color changed automatically. It has enough data for us to run this. The next information here is the lens length. So in our Rhino environment, the default preview angle is a 50mm lens. If we want to check that, if you go to your properties, you'll see that our lens length is set to 50. If I change that to, let's say, 35, you'll see that my view is starting to change. If you want to see more of the object, you would make this number smaller, but anything lower than 35, we're starting to see a lot of distortion. So this numbers, let's say 24, would work well for interior views that you want to show more of. But if you want to just focus on your object, between 50 to 35 is what you want to focus on. So let's go back to our definition and set up a slider for our lens length. And I'm going to set it up to be between 24 less than 35 less than 50. So that's the range we're looking at, and connect that to lens length. We have an option here to also provide a vector for the orientation of the camera. This is not going to make a big difference because often the main two variables that are important is the location of the target in relationship to the camera. So let's leave that out for now. And then we want to activate that. So right now, my view is whatever I have set up in perspective. However, if we activate this using a Boolean toggle, our view is going to be overwritten by whatever we have set up here. So we can immediately see that my view is from the camera point to the target point. So if I change the location of my target, we should see our camera is starting to reset itself. So the point is going lower, so I'm seeing more of that. And if I want to change anything about that, as soon as with my mouse, with my panning tool, if I start to change that, I could reset that, but as soon as you reset, your view is being triggered. So right now it's a little bit better, right? Because I could see more of this. So it's a little bit higher. We can start to work with our lens length. So you could see that smaller the number, further away we are. 50 is pretty up close. So it's up to you how you want to set up the angle. In this case, I'll do 35. Now I could go ahead and do the same animation here, but as you can imagine, we would only see the geometry emerging. And in this case, our camera is not really active or responding to our geometry. So in the next exercise, we're going to look at how to incorporate and kind of complement the way that our geometry, our data is being represented with the camera view that we have set up. So let's go ahead and open the Rhino file that I've provided for you. I'm not going to change anything here. I only have the points selected here, but we're gonna build on this definition, so I'm not going to save that. I'm going to go ahead and open 607 animation tutorial, and let's go ahead and start a new Grasshopper definition. So if we look at the Rhino file, this is a portion of a city that is important using elk. Then the volume of each building is being represented with a different color using color gradient, but my geometry is in Rhino. So these have been baked using Giulio Piacentino's custom C# color attribute component. And if you look at your layers, I have a ground plane, which I've locked. You can extend this. I have my buildings, which is my active layer. So you can see that these are just B-reps or polysurfaces that we can select. I also have another layer called camera path. If I extend it, you can see that better. Camera path, which is turned off. If you turn that on, you'll see two camera paths. So I've already preset this for us, so we'll be able to animate and go along the street and plot data using these. All these are just, this one is a polyline that I've set up with a fillet radius here, and then I've taken the same polyline and scaled it up and slightly adjusted so then it would work when we want to look down. One thing you want to pay attention to is the direction of your curves. I'm going to select both and then type dir to make sure that they're both going in the same direction. So then I'm going to use this as the direction of the animation path that we want to set up. So for the first portion of this exercise, we're going to only work with the low camera path. So I'm going to turn off the high one. And let's call our Grasshopper. And we're going to reference the path that we're seeing here, the red line, using a curve container. And I'm going to use a curve container, right click, set one, curve. So that is going to be our camera path. We're going to use Horster, so I'm going to go to Horster, camera, and use the set camera component. And we're going to try to work this based on the setup that we have. But if you pay attention here, my camera location is a point. And what I do have here is a curve. In the previous example where we set up a point, in that case, we had one object that we were looking at. In this case, if this is my path, and if I want to look at a point, if I put that point, let's say right in the middle, I'm not going to be able to see that because there's buildings in front of me. So what I would want to achieve here is a point that is going along this curve and a target point that is always in front of my camera. So we're going to extract the point on this curve, and there's a few different ways of doing this, but keep in mind that what we eventually will end up animating is a slider, because in the previous example, if you remember, our Horster was static. We were animating our slider for the geometry. So we're going to go to our curve tab under analysis subtab, look for a component called evaluate length. And we're going to use this component because what it does is it takes a curve and we can pick a point along this curve based on the length that we're providing. So length is a value, but I do want to be able to use a slider in this case, so then we can animate that. I'm going to grab a default slider, and if you place your slider here, you'll see that by default, when I'm at 0, this is at the beginning of the curve. I'm going along, and 1 is the end of my curve. So it seems like this component by default is understanding the length of my curve as a parameterized value, meaning it doesn't really care how long my curve is. If I want to check that, I can select my curve in Rhino, go to Analyze, and use a length command, and you can see that definitely this is not one value. My curve in this case is 2,452 meters. So there's an option in this component called normalize or parameterize, and this is a Boolean option. If this option is true, my curve will be parameterized. So it would assume whatever the length is, it would be remapped between 0 and 1. But if I turn this off, the same curve, you can see that with between 0 and 1, it's just barely going forward. We can't even see it with the scale. You can kind of see the point moving. So make sure that you have this option set to true. So now that I have a point traveling on my curve, I could use that as my camera location. So I'm going to group these components together. I'm actually going to keep my slider outside, but my curve, as long as evaluate length, group them together and say this is location of camera. Okay, so we're going to be doing the same thing for our target. So in the sense, we do want our target to always be traveling in front of us. So we not only will be using the same component, but we have to make sure that our position of the camera is always larger than this. So I'm going to grab our evaluate lens component, make a copy of that, move it down. And in this case, I have 2 points, one in front of the other. So what I'll do is I would just do a simple addition before I connect that to evaluate length. So I'm going to go to math, under operators, use an addition component, and say whatever the length value is plus another value. So let's make a new slider. I am going to grab another default slider, but I need to make sure that this is not starting from 0. So I'm going to right click on it, go to edit, and instead of 0, I'll start from 0, 1. That would be the beginning. However, if I'm adding this number to the slider, by the time this gets to 1, this is going to throw an error. So whatever I'm adding here, I need to subtract it from that domain. So I'm going to right click on this again, go to edit, and say our maximum could be 0.99. There we go. So now they are complementary. Okay, and we're going to add these components to a group. I'm going to leave the slider out as it's going to be the slider that we'll be animating, and say that this is our target point. Target. Right, and we're going to feed that as the target location. Then, similar to what we did before, we're going to send out a lens length. I'll be doing 24 less than 35 less than 50. I'm gonna connect 35mm lens, and all we need to do is to activate this. So I'm gonna say that set to true to animate. Okay, so as soon as we set this to true, we are along that path. And if we go to our number slider, I'm going to right click on it and say that this is our animation slider. If we are moving along here, we're able to go through this path. So as you can imagine, if we start to animate this, we would be able to extract still images of this process. So what I would do in this case is I would hide the curve. I would also hide the location of the camera, so we're not really seeing any of that. And let's go ahead and animate the slider. Right click on the slider, go to animate. It would again by default send it to the folder that we have preset. I could call this the same name to replace it, change that. I can I kind of inherit the size of our screen, and instead of 50, let's do 10 animations. Okay, and we're able to go through this. So you can see that it's a nice walkthrough. And this is a great method for you to quickly, let's say an urban project, show us how what you're proposing or your environment is could be viewed using first person perspective and camera. So I'm going to delete this, go back to our definition. The next thing we want to set up is a little bit more information about our site, right? So I'm going to go to the beginning. We have our animation set up, but it's a little bit boring. One of the things you can think about when you are in this first person view is perhaps displaying information about your side. So first thing I'm going to do is group everything together and make sure that we are naming this in a way that we know what we have here. And this is our poster animation. And I'm going to say that this is first person view. So using terminology from games, first person view, and we're going to keep this for now. Next thing I want to do is I want to add a little bit more information to our buildings. So our buildings are baked in our Rhino environment, so I want to reference them. So these are BREPs. We'll go to parameters, grab a BREP container, and right click on it and tell it to do set multiple BREPs. We can set this up in a few different ways. It's ready to reference BREPs. I have my buildings. I can right click on buildings and say select objects. Now those are selected, and then right click. Now those are stored in my container. And at this point, because I don't want to have these double preview, I would actually change my default to ground and turn off my buildings. So at this point, one of the things I could look at is to display information about these buildings, such as, let's say, their volume. I don't have any other information right now that I could be showing, but let's say we're working with meerkat or elk, it could be information about their type, about the year of their construction, whatever information we would have in our GIS. So going back to our Grasshopper, we have these BREPs stored. So I want to calculate their volume by going to surface analysis volume, and this one not only provides the centroid curve, but also the volume of each of these objects. So therefore, I have a point that is right in the middle of each of these, but the distance of this point from ground level is different. So keep this in mind. We're going to be using this information later. But one of the things I could start to do with this is to start to think about markers, so lines that are coming out of these points that could start to kind of point to each building and tell us perhaps their volume. So I'm going to grab the centroid point and create a line marker from each of these centroids by going to curve, primitive, and using a line SDL, start, direction, and length. So start is wherever the centroids are, directionality is moving up, and then length, let's set up a slider, let's say 100. And if you do that, we'll see that from each of these, we have a line coming out. But if we look at these lines, it would be a little bit strange if you're drawing a diagram, if you're trying to show this as some kind of an information indicator. These lines are coming out of the building. Usually when you have geometry touching, it would mean that it's something that is constructed, so it might be kind of mistaken for antenna or other type of information. So if we want to just use this as indicator, we would have a line that is barely touching the building, but there's space in between, right? So in this case, I'm going to reconstruct this curve. So I have these lines constructed. I'm going to go to curve analysis and use a component called endpoints. And I'm going to redraw this curve, but from top down this time. So I have the endpoint. And from the endpoint, I'm going to draw back using the same component, which is line SDL. So I could just make a copy of that right now from the end. But I don't want it to go up this time. I want it to go down. So instead of positive Z vector, which is preset here, I'm going to go to our vector tab, vector subtab, unit Z vector, but I'm going to reverse that vector. So you can either reverse it first or input it later. So I have the factor here. I'm going to reduce this to, let's say, 60. Provide that to the scaling factor, take the unit, reverse that, and then provide that as the direction. So now if we look at these, you'll see that it's not the whole. I'm going to take my original curves and turn them off. So you'll see that they're more of an indicator. Perhaps we want to change that to something like 70. All right. I'm going to turn off my start and end extraction as well as my centroid. Okay. The other thing is, if this was, let's say, a diagram that you would be constructing in Illustrator, perhaps you wouldn't be working with solid lines, right? So this is quite important because it used to be the case that you would take your diagram out of Grasshopper, you would put it in Illustrator, you would do all your line weights there, but there's few really useful components that would allow you to apply this diagram and kind of construction and drawing quality in Grasshopper environment. So first thing we're going to do, we're going to make our straight line dash lines by going to our curve tab under division. Use a component called dash pattern. So this component takes a direct line and it requires a pattern. So the pattern is ultimately the gap length between the pattern that we're constructing. I'm going to actually turn off my original line and create a slider which is 0.1 less than 2 less than 5. 0.2 should be good enough, and you can start to see that these are these beautiful dashed lines that work really well if we wanted to look diagrammatic. The next thing we're going to do is we're going to apply color to this. But keep in mind that if we want to print screen this or screenshot this, these lines are barely going to be showing, right? So one thing we could do is in Human plugin, which you'll find it again on Food for Rhino. We're to go here, Human, which is a type of animal. Here, these are fantastic representation tools. So look at the latest version, and it has this extremely useful tool on the display called Custom Preview Line Weights. Custom Preview Line Weights that will take your different curve type geometry and you can apply a color and thickness to it. So I'm going to grab color swatch, keep the shader white, and then the thickness, whatever you see in your screen when you print it, is actually going to be a little bit lighter. So don't hesitate to make this a bit thicker. I'll make a slider 0.5 less than 3 less than 5. So they're going to be a little bit chunky, but this is going to look good when I print screen these. So this is very, very useful. The next thing we're going to do is we're going to actually print a text information. In this case, perhaps we could print the volume of each of these buildings right above these indicators. So there's a few components that we could use for text tagging, but the best one that would work really well when we're doing animation is again in our Human plugin. And the reason for that is that this specific text tagging component would work well with angle of the camera. So if we go back to Human under display, look for a component that says screen oriented text. And the text that we want to be printing, in this case, could be the volume information. So go to your volume component, and that's the text that we want to be displaying. So by default, there's nowhere for it to be displaying. So it's asking for a location. And guess what? Earlier, when we extracted the endpoint, we could use that as the location of the text. So they're really small right now. Let's make a slider for the size factor. I'm going to go to less than 8, less than 14. size factor. So we're starting to see the text printed. So a few more variables here. We can do justification. If I right click on it, I could do different types of justification. So I can do middle, center, right? Or perhaps we're gonna do bottom left. And the other thing we can set up here is the color. So perhaps our color could correspond to the same color as our indicator. But one thing that you're noticing is that my volume has a few decimal places, and it becomes quite confusing. If we go back to our camera here, so I'm going to preset this or reset this, you'll see that there's quite a lot of digits, right? So we want to simplify this somehow. Also, we're noticing that the color of our text, which is same as the color of the indicator, becomes quite messy. It becomes difficult to see that. So we're also going to change that. So I'm going to look for a component called round under math, under utilities. We're going to have our rounding component, and we're going to provide the volume as an input here, and it's going to round it to the nearest, and we're going to use that as the text that we're displaying. So automatically you see that we don't have the extra digits anymore. One thing that's important is that when you're doing data visualization, you don't want to just show numbers. You also want to tell us the units that are associated with that. So in this case, we have cubic meters. I'm working in meters. So we're going to add that to the text that we have here. So anytime that I have text data or string data, and I want to add more to that, we would do something called concatenation. So if we go to our set, under text, we have a component called concatenate, and this one allows us to stitch text together. So first thing is, what is it that we want to start with? So these are the rounded numbers, and what I want to add to it is, in this case, and I'm going to use the symbol for replacing the cube above, and we're gonna use that as our concatenation text input. But one thing I could do is also, before inputting that, create one or few spaces in between. So whatever we provide in the panel is what will be visualized, or what would be stitched together as a text. So you could see that we have now the units there, and I can provide that as the text input. So we do see that as well. All right. So next thing I want to do is I want to change the color of the text so they're not really clashing with the length that with the lines that we have. And what I want to do here is I want to adjust the color based on their proximity or based on their distance to our camera point, right? So in this case, I could say maybe the ones that are closer are darker, and then maybe they're fading away. So we're not seeing everything overlaid onto one another. So I'm going to be using the position of my camera or the position of my target, whichever one we want, as a point that I'm measuring the distance of these endpoints to. So we can use a distance component under vector point distance, and I'm measuring the distance of my target point, and I'm measuring its distance to all the endpoints we have here, right? So all the endpoints. So what we will be end up having is series of distances that are corresponding to the relationship of the text to their target point. So if they're closer, then I'll be able to identify that. And using this setup, apologies for this mess, I'm going to move this down so we have room to do a color gradient component here. Using this setup, now I can apply a color gradient to my text, and that's going to be the input of our color. Right now we're using a uniform color swatch color. So by going through prompts, input, gradient, what I want to apply color to is all the distances, so that would be the parameter that we want to map. Now I need to know what is the lowest number and highest number. For that, first I need to detect the domain. So if I hover over it, it would say it's between, in my case, 154 or something and 2740. These are the points that are way back there. And I need to deconstruct this domain so that I'm able to provide the minimum and maximum as the inputs. And ultimately, that color gradient is going to become the color input for our text. So you're starting to see that that works a little bit, but because this color is too similar to our buildings and the difference between colors is not too drastic, I'm going to right click, go to presets and pick something more drastic. This is up to us how we want to identify this. So for instance, we can right click and pick something that we can adjust better. Maybe if by going to this, I'm going to right click on the input. Maybe I'll use something darker like blue. I could go a little bit lighter blue. So I would maybe do like a cyan color that really stands out. And then I could also change the color of what's in the back so it's a little bit more atmospheric. So absolutely up to you. And we want to try to see what this is going to be this is what it's going to look like when we're animating it. So we can start to see that always the ones that are close to are blue, and then as it's going in the background, the color is changing. And again, as I mentioned, these lines are a bit thick right now, but if we were to export them, you'll see that they don't have the same kind of dominance. Next thing we want to do is we want to apply also either color to what we have, or if you remember, these are already referenced from Rhino. So I'm going to turn these off, and I would go to my Rhino layer and make sure that my buildings are on, right? So let's go ahead and test animate this. So I'm going to my Horster slider and tell it to animate. Same folder, same setup. Instead of 10, let's extract 20 frames. Okay, so walking through, I'm seeing the relationship of the text to the camera, and eventually you can see that this is working. So now that you see what the dash line looks like, then depending on your taste, go ahead and adjust the thickness. So I'm going to delete these again, and we're gonna continue making our camera angle a little bit more interesting and plotting a data that we can start to visualize, and it would follow the path of our camera. I'm going to organize our definition at this point. I'm going to group all this bit together. And I will say that this is site visualization. Next step, we will generate another Horster animation setup. And this time we will be using our high camera pad that we have set up here. So we will move our camera up to this blue line, and we will be still looking at this lower camera path, but we would only consider our target path along this curve. So at this point, the setup that I have to do is actually quite similar to what we initially have here. So I'm going to make a copy of this whole setup. Control-C, Control-V, and I'm going to move it behind our first Horster setup. I'm going to change the title of this. This is Horster Animation First Person. And instead of first person view, we would change that to aerial view. Right, and we want to make sure that we are referencing the top curve in this case. I'm going to go to my curve container, right click and clear values. Right click and set one curve. So select the top curve. Now you're starting to see that as I'm selecting elements, every time that we're triggering this definition, our camera view is changing. Right now my camera view moved all the way up here. The reason for that is that not only I have my initial camera activated, but I also have a new camera. So this could be confusing. It's better for you to do one camera at a time. Otherwise, if you're not careful with the sequences, your view would constantly be adjusted. I'm going to turn off the Horster component for the first person view. I'm going to only look at the top view. And at this point, what we have set up is that there's an initial curve and the target point is following the initial curve, but I don't want to do that because as you can see, my view is quite high. And in this case, what we want to be doing is we want to reference our lower curve. So I'm going to select this group and delete. And we want to go back to our first person view camera and take the target point and connect that to our target location for the second camera. We can keep our lenslet as a separate variable in case you want to adjust one separate from the other. And you want to make sure that your first camera is turned off. And let's take a look at the view that we are creating with the second camera. I'm going to move the slider forward. And we're starting to see a more aerial view. And I'm looking at the first curve. And then eventually the length of my first curve is ending. So therefore the camera or the target point is moving slower on the first view. And I'm able to look back. Now you can go ahead and adjust the location of these curves. However much you want to do that. All you would do is you would go to your initial curves and you would start to think about how by adjusting either its control points, versus here perhaps I want to go back a little bit more, but every time you reset this, our camera path will be reset. So if you don't want to do that, make sure that you turn your toggle off, and this way you can make your adjustments independent from activating the camera. Right. So this is the part that you would spend some time finalizing the view, exactly what you want to look at. But in this case, what would be important for us is to have something on the ground that we are looking at. Otherwise, what is it about this animation that is important, right? Because if we were to only focus on the numbers that we plotted, the first person view was much better. So this is where we would focus on generation of, in this case, a data plotting over time. And in order for us to be able to work with a dynamic variable that we can adjust, I would like to introduce the Firefly plugin, which would allow us to work with dynamic inputs and outputs. So if you go to a website called fireflyexperiments.com, you would be able to download the Firefly plugin directly from this website. You can also access this by going to Food for Rhino, or as well as from Grasshopper 3D website. So if you go to download, this is where you would scroll down, provide your information, and click to download. And you want to make sure that you are downloading the 64-bit version of Firefly. When you do download this is an executable MSI file, so you would have to make sure that your Rhino and Grasshopper is closed when you're running this. When you do this, if there's an older version, it would be replaced. And next time when you open Grasshopper, you would have a menu called Fly, and under here we are going to have a series of components that are dealing with either data input and output, data management, and different types of data. The one that we will be working with for this tutorial is one of our audio tools in order for us to be able to capture an environmental sound and use that to plot over this camera path that we have set up. So I'm going to use a component called sound capture. I'm going to move that over here. I'm going to work on this area. And if we look at sound capture as is, time period, if you hover over it, 0.1, and this is time period in seconds, and then there's an option to turn on or off, or true or false, or start or stop our sound capturing. In this component, we're breaking down our output into left channel and right channel. However, if we look at the output of volume in general, this would be a summary of right and left channels. So right now it's just capturing one value. If I grab a Boolean toggle, and if I set this back to false, set it back to true, and that value is going to be different. So every time that I speak, every time that I do the input and output, the value will be different. So this component by default is static, and anytime that you're working with a component that has the option to take in time interval, we could use a component called timer under params utilities timer, which doesn't really look like any of the components we've used before. If you right click on the timer, go to interval, you would be able to pick the frequency of how often your data can be updated. So for instance, if we go to one of the lowest, which is 20 milliseconds, or you could also adjust the values here in the box. I'm going to select 20 milliseconds, so that would be quite fast. And the way you would connect this, it's not really to a specific input, but to the whole component. So first I'm going to set my start and stop to true. Then you want to left click on the arrow here and drag out a wire and connect it anywhere to your component. And you'll see that you'll be able to move this around. And as soon as we do that, we see that the sound capture volume is starting to increase. So if you start to speak louder, you will see the values are increasing, but also the sampling is happening every 20 milliseconds. So it is capturing based on, it is capturing quite fast. Alright, so next thing we want to do is we want to be able to record this data and be able to look at a list of volume data that we can work with. Now, basically what I want to be doing here right now, every time that that it's calling this to get the value, it's replacing the previous value. What I want to say is that store all the value, create a list. We are going to go back to our Firefly component, and under utilities, we have a series of components that would allow us to manipulate the data after we capture it. these components, a few of them are very similar to our remap component, which we use a lot under math domain. So if you ever come across, let's say, limitations with the remap numbers, if you go to Firefly under utilities, these components here, smoothing temporal and smoothing moving average and constraint, they would help you to limit your data more. So we're going to use a component called data log. And data log would allow us to store this information as a continuous list. There's a few variables here that we can set up, and I'm gonna place a panel here for the output just to be able to see it as it's starting to log. And I'm going to connect this data to incoming data, and we'll see that automatically it's starting to log the data. Now, frequency of how often this is being written or updated is based on our timer. And if I just keep scrolling down, you'll see that it just keeps logging until I stop doing something, or if I set up a condition. So the next input here is a reset log option. This is false, meaning it's not resetting itself and it keeps recording. And I'm going to go to params and grab toggle. So I'm going to set this to true, and you can see that when this is set to true, it pretty much erases everything, and it's just recording similar to what we're seeing here. So I'm going to group this to itself and pretty much say that's set to true to erase data. Right. Next option here is start or stop recording. Again, this is a Boolean toggle, and we'll see how these two work together. I'm gonna move that to start recording. Nothing happened. Set this to false. It literally stopped recording. So this is the engine which would run or stop this component. So again, start, stop, but it has nothing to do with the data that we're logging. So this is the engine of the component. I'm going to group that to itself, and this is record data or stop recording data. Okay, so in this case, if I want to keep recording, I'm going to first turn this on. Yes, keep updating yourself, and then I would turn that to false. So now I'm recording again. But what if I want to have a limitation? I don't want endless data, and this is where our recording length comes in. So if you don't set up a value, if the value is 0, it would record to infinity. I'm going to set up a slider here, 1 less than 100. Recording length. Now, if I do that right now, it's going to stop because this is clearly past number 1, right? So I would do this thing. I would reset this, and I'm going to also turn that to true and turn this back to true. So it goes back to recording only 1. It's not logging. First, I'm going to move the number to 100. Then I'm going to tell it to not erase itself, basically. So I'm going to turn that to false. So this is going to write until it's 100 elements. We should see that stopping soon. There you go. So it's not replacing anything. It's not doing anything. So at this point, I could come back and also turn off my sound capture. So then this way, we're not really influencing this data. If you ever want to also turn off your timer, you would just be double clicking. And if you look at this preview, this is similar to enabling or disabling. So if you click on it and do Control E, you would be able to enable or disable. So I would also disable this. Okay, so we have our data, and we want to plot these values on this curve that we have. And first thing we're going to do is we already have the curve reference, right? So our curve reference is from our Horster component. What I want to do though is to take my curve and divide it into number of points, and the number of points should correspond to number of recording that we have in here. In this case, it's from 0 to 99, so that's 100 items. So therefore, I'm going to come back to my initial curve on the ground and grab a divide curve component under curve division, divide curve, and provide the curve as the geometry input. Now my count should come from this slider here, right? This is how many elements I want to be recording. But if I input this as is, I'm going to look at my points. I would be getting 101 points because this component, it's dividing and it's ultimately creating however many inputs I have here, that many segments. If I scroll down, my point is going to be 0 until 100, so that's 101 items here, right? So just to make sure that my data is matching, I'm going to write an expression here. So it's an internal equation that would allow me to subtract 1 from whatever that input is, because that number is always going to be 1 more. So I'm going to right click on count, go to this thing called expression, and here my input, I can just assume that it's a generic variable, so I can call it x, and I can say x minus 1, and it changes, right? So right now that number internally is going to turn to 99. All right, so we have our points, and next thing we want to be doing is we want to plot straight lines coming up, similar to what we have for our building indicators. So going back to curve, primitive, line, SDL. So we want to be taking our points, provide that as the start point. So we see them, but they're very small. And what I want to be doing is I want to take the length, and that should be corresponding to the audio values that we have captured. But if I connect that as is to the length, we'll see that these are quite high, some of them. And it would be difficult to kind of analyze them this way. So we will be doing remapping with this. So if we go to our math domain and do remap numbers, I will be taking these values. Now I need to know their bound, their minimum and maximum as my source domain. And I would be constructing a new domain as my target domain. And for the target domain, I'm going to be constructing it to based on, let's say, a slider that is between 10 less than 100. And obviously keep in mind that the data that we recorded, which is background noise in wherever you are, it has nothing to do with this specific site, but we're just using it as a generic input in this case. Eventually you can substitute the audio recorder with either a sound sensor, or you could travel with your machine and capture audio, and you should be able to, with this setup, do live plotting. Right, so now instead of the initial length, we would be using the mapped length as these values. If we look at them, they're a little bit more normalized, so we could see them better. You could definitely play with the minimum and maximum. So right now, for instance, between 40 and 100, right? And when you have a graph like this, one thing that would really help is for you to also be able to draw the overall curvature of, in this case, the soundscape. So I'll take these lines similar to what we did before. We would extract the ends and points, and I would be taking the endpoints, and this should be one continuous list of points, and I would be drawing a polyline through them, through all the endpoints, right? So now if we look at it, we have the lines and we have these waves that are explaining kind of their relationships. I'm going to grab custom display component under display preview, custom preview, and I'm gonna visualize the sound wave separately, and I would be using color swatch for this as well. Okay, so in sense it stands out. And as you can imagine, we could do quite a lot with this audio tool. We could also start to add a color gradient to it. So to do that, I would grab my gradient component. I would use the values that are constructing the length of the curve, the map values, as my parameter. But if I want to extract the lowest and highest, right, we can either grab them from these sliders that we already have, or we can repeat this process. And so sometimes it's better to repeat it unless you're gonna make sure that your gradient stays here, but eventually we're gonna be moving our gradient to a different part. So therefore I'm gonna be repeating this part. So again, from the map values, I would be getting the bounds, and I would be deconstructing the domain. The start, that's the end, and if I were to display my component, these case lines, my lines are coming from here. That would be the gradient. I'm gonna make it more exaggerated so we're able to see that. Let's look at our environment. So I'm gonna select and hide my animation curve and go back to our second Horster animation simulator. I have my animation activated, and let's look to see what we're looking at. So I'm starting to hover over the simulation. Then I'm looking at the top view, and eventually, because the top curve is longer than the bottom curve, we're kind of looking back. Again, you should spend time fine-tuning the paths based on whatever you want to capture. Right, so next step, what I want to do is I want to also animate the way that this point is being created. So in a sense, we wanted to make it look like you are plotting the data, or capturing the data as the camera is moving forward. So instead of seeing them all at the same time, I want to go back to my geometry here and look at all my curves. I want to be able to see them one at a time. So at this point, I'm going to move my gradient part over, and I'm going to turn off the preview. So I'm looking at all the curves at this point. And one way I could do this, right now all of my lines are in a continuous list, and I want to see them appear one by one. And one method of doing this would be if we create two lists that by moving a slider through their indices, we're always transferring one item more to the first list. So we're going to use a component called split list by going to set list split list, In this way, we will generate two lists. One is the list of elements that have been plotted, and then the list of data that is waiting to be plotted. I'm going to connect the list, in this case, list of all the lines, and based on the indices. In this case, our indices are starting from 0 less than 99. We have 100 items. If I look at the output, by moving this index, we're able to create two sets of lists. So in this case, what I'm interested in seeing is items that are coming out of the first list, right? So we want to make it look like these are appearing. So this component by default shows both. So I will grab a curve container and just look at the outputs from list A. I will turn off all of my curves along with my split list component. And I'm going to fix my view in the sense that I could see just elements being plotted. So I'm starting to change the indices. We're starting to see more and more of these elements being plotted, right? And since this operation is done using a slider, by animating the slider, we would be able to also animate this plotting. But the problem is that animation allows us to work with time and updating information in Grasshopper, and Horster, by default, it would only work with animation of one slider. And in this case, what is really important for us is the position of the point on the curve, and that is all determined by this slider, which could only be between 0 to, in this case, 0.99 or less than 1, just based on its relationship to the target. So then somehow I need to be able to animate this one, but this should also respond to the split list slider that we have. So we're going to actually remap the number in a sense that the number between 0 to 100 is corresponding to this. So we're going to grab our remap component, and the number that we want to remap is always the value of the slider, so one single value. Its source domain is the extent of this domain. So I will construct a new domain, and since the construction of this domain is based on this slider, I can just make a copy of it twice. And at this point, I'm gonna grab all my remap components, and I would move them to this area. So this becomes our source domain. The start is 0. The end is 0.99. And my target domain is what this slider is. Again, I would construct another domain. But in this case, the target domain would be between 0 to 99, and that would be my target domain. So now with the same slider, we should be able to control this one. But if we look at the output here, the values that are coming out, in this case, let's say if I change the input, I would be deleting these. Let's say a value here. When I look at the output here, this has 1 decimal place. So if I want to use this as the index, it would still work. But it's always good to practice to make sure that the value that you have is of integer type. So there's two different ways that we can do this. We can either round this number by going to our math under utilities and grab a round component. This would round it to the nearest value, right? Or this is a data type. So our floating point is a data type. If we run that data through an integer component or an integer container under params primitive integer, it would also convert it to an integer. So it's good practice for you to always make sure that your data is the right type, but nonetheless, this would be working this way. So in this case, I would actually be using the integer container for us to just have this for practice. And I would actually align it here. And then that value is what is going inside our index that we are separating. Now let's test the logic. I would before that turn off a few preview elements. So for instance, our start and end point, select the control Q, and we're going to keep our lines as is. Now these points that I'm seeing here, they're coming from my divide curve component. So once we do that, let's go back to our top view or aerial view raster component. My view is activated and I'm testing to see how much I'm seeing. And as soon as we start to move the slider, we're seeing the lines being plotted. So this needs some work. It requires some thickness. It requires color. Nonetheless, we're starting to follow the data plugging, and it ends. I'm going to go to the beginning and start to add a few more attributes here. Let's go back to what we have set up here. Initially, our color was corresponding to all the map values, but what we could do here is to look at another quantitative element, such as measuring the length of our curve, and start to create this variation based on the length. Now keep in mind that that is ultimately what is determining the length, right? So this is completely up to you how you want to set this up. In this case, we could say that the parameter that I want to be mapping always, it's going to be the length. So this could be singular or plural. So that data doesn't exist yet. And my bounds would still be the same, right? Because they are coming from the same values. If you're not sure, it's always good practice for you to reset this. So we would pretty much repeat what we've done multiple times. You have the bounds, you have the start and end, but in this case, we could look at the bounds of all the curves, right? And then start and end. Again, these are the same numbers, right? Because that input is what's providing the length. Right, and last thing we want to change here is the geometry that we will be displaying. Our geometry would be the curves that we are splitting. So right now our curves are not drawn yet because my splitting value is set to 0, or it's controlled based on the animation slider. And also if we want to be drawing the graph over the curves, I also want to make sure that I'm not looking at the whole graph, but just the ones that are being plotted. And I'm going to turn on the preview for this, as well as for my gradient. So we have everything set up right now. Let's go back to our raster component. And I would first test it. At this point, I would select and hide my preview, my camera path. As soon as I start to animate, this would go to the original, but if you just reset this, that's where my camera is set up again. Before doing that, you could also play with the camera angle and say how much do you want to be seeing. So lower the number further away I go. So I prefer 35, but it's up to you and based on your view. And I'm gonna start to animate this, and I do see the curve being drawn as well as the points, the curves being plotted. So a few things here that I noticed. go back to the end and make these adjustments. I forgot to turn off the preview of my curves, so that's why we weren't seeing color. Also, instead of displaying this with the default custom preview, I could also use a line weight component from Human. Under Human, display preview, custom preview line weight. And it's the same setup. The geometry that we're showing is the same. Shader is this. All we have to provide is a thickness factor. And in this case, let's go with a slider that is from 1 less than 5. I'm going to provide 1 point decimal. And let's see, something around 3 should be good. And we can definitely come back and change this. I'm gonna go back and test my animation. So there's a lot of back and forth in this process. Yeah, now I can see that better. I can see the color. It's integrating well. One thing that you might want to do is to distinguish the color of the buildings from this. And I could go back and change the gradient color to something that is maybe differentiated. Now at this point, if I like what I'm seeing, I can then produce the final animation. So I would then right click on the slider, animate. I'm gonna browse and select my GH animation folder. Okay. I would either render it as JPEG, PNG, keep the name or replace that, and I would go with my window dimensions, and I'm gonna press OK. There we go. And obviously, if you want your animation to have more resolution, you would be extracting more frames, but we're starting to see how our preview is starting to take shape. So if you were to animate this, this would be quite short and jumpy. So since our slider could have a lot of divisions, so we could ultimately extract almost 1000 frames from this. Perhaps going with a higher number, at least 100, would be good. Right, hope you enjoyed this tutorial, and thank you for watching it.